All right. Ooh, I need to back up. All right, today's lesson is understanding chemical formulas. And just like we talked about from the warm-up, this is going to be really important as we balance chemical equations in the future, showing the law of conservation of mass. But before we can do that, you have to know how to count atoms. And there are 3 different hints or rules that you're going to need to help you do that. Subscripts, parentheses, and coefficients. Those are 3 terms, SPC. And we need to learn what those things help us determine when we're trying to count the atoms in a formula. So let's start by reading about subscripts. Okay. Subscripts. It's giving you an example of a subscript, and you've gotten fairly familiar with these as you've been writing formulas to represent ionic and covalent bonds. The 2 in this example of BAF2 is called the subscript. It only refers to the element preceding it, directly preceding it. Now, that's an important word. What does preceding mean? Blake, what does preceding mean?
Coming after? No, coming before. Yeah.
Good. Coming before. Pre meaning before. So what that shows is the subscript applies to the element coming directly before it. And if you want to, you could even write before there. Okay. In this case, it applies to the fluorine directly before it. And I like to draw arrows to show what numbers apply to which elements. So therefore, it says in this case, we have 1 barium atom and 1 fluorine atom. I'm sorry, 2 fluorine atoms. 2 fluorine atoms. So those are subscripts. They help us determine how many individual atoms of certain elements we have in a formula. Then we also have parentheses. In some chemical formulas, it is necessary to use parentheses. The subscript on the outside of the parentheses is going to refer to all of the elements inside the parentheses. So let's underline that. That's very important information. The subscript outside the parentheses refers to all of the elements inside the parentheses. So then look at your example. We have AlNO3 with a subscript outside the parentheses of 3. So then this 3 is going to apply to everything inside the parentheses, including the nitrogen, including the oxygen. Does it apply to the aluminum?
No.
It does not, because the aluminum is not inside the parentheses. So, as we see here, it tells us in this example, there's 1 aluminum. The subscript of 3 applies to the nitrogen, so we have 3 nitrogen. It also applies to the O3, so we multiply our subscripts here. We have 3 O3s, giving us how many O's? 9 oxygen atoms. So that's parentheses. The last thing you need to know, and this is the word we were trying to think of earlier, we knew that there was a big number that represented the number of molecules of a compound that we have. We call them coefficients. So the large numbers to the left tell us how many molecules of a substance that we have. The 3 in this formula is called the coefficient. It refers to each element that follows. Okay, let's underline that. It's important. It refers to each element that follows. So in this case, it will apply to the barium, and it will apply to the fluorine. Again, you're going to multiply everything by this coefficient. We have 3 barium, and how many fluorine? 3 times 2. And that's it. those are the helpful tips to help you count atoms. Now, some get more challenging when you have coefficients and parentheses and several subscripts, because then you're multiplying several things several times, but we're going to practice that. So I want you to take a look at the examples at the bottom that are already done for you. Okay? You'll notice that it's counting up the individual atoms and then showing a total number of atoms in the formula. You'll want to be careful on quizzes and tests going forward to make sure that you read the question carefully to know what's being asked of you. If it says, how many individual atoms do you have? You'd want to write them out. 1 potassium, 1 chlorine. But you might see questions that say, how many total atoms do you have in this formula? In which case you would want to show an added total of all of the atoms in the formula. So just be aware and careful of when you read test questions in the future that you're actually answering what the question is asking you. Is it asking for individual atoms, or is it asking for the total number of atoms in the formula? Are there any questions about these examples as you're looking them over before we start our practice? All right. So if you'll move on to your practice page, they start fairly easy and work their way to more challenging. Now, I'm going to ask you, do you want me to work the first 2 with you, or would you like to just try on your own?
On our own. On our own.
Okay. All right. I have enough work the first 2. How about I'll work the first 1 and then let you try. We're going to go over all of them at the end, okay? So let's go over the first one together just to make sure. Do we have any parentheses, Katie Grace?
No.
No, we do not. Do we have any coefficients, Sarah?
No.
Do we have any subscripts?
No.
Aha, I tricked you. The first one's easy. All right. So how many sodium atoms do I have in this formula, Seth?
Like one.
1. I have 1. Exactly. How many chlorine, Aniko? 1. For a total of, you guys are brilliant, 2 atoms. All right, I want you to try the others on your own. All right, I'll work through number 2. It has parentheses and subscripts. All right, if you feel confident thus far and would like to move ahead, that's fine. We'll be going over all at the end. If you're feeling a little insecure right now, you're welcome to work along the second one with me. All right. We have Al, C2, H3O2, and a subscript outside of this parentheses at 3. Okay, so we don't have any coefficients. That's nice. Some people accidentally mistook this 2, which is our question number. That is not a coefficient. Okay, so we have a subscript of 3 here that's outside of the parentheses. And if I look back to the information that we have on the other page, it tells us that a subscript outside of parentheses applies to everything in the parentheses, but nothing else. So this subscript of 3 is going to apply to everything in the parentheses, the carbon, the hydrogen, and the oxygen. The aluminum's on its own. Loner. Therefore, in number 2, I only have 1 aluminum. It's all by itself. It does not have a subscript, nor does it have a coefficient. Okay? Then I'm going to multiply the elements inside of my parentheses by my subscript. I have 2 carbon already inside the parentheses. I need to multiply that by the subscript outside. 2 times 3 is how many carbon? Okay. 6 carbon. Then I'm going to do the same thing to the hydrogen. I already have 3 hydrogen within the parentheses. I'm going to multiply that by the subscript outside of the parentheses. 3 times 3, Hunter? 3 times 3.
9.
You have some helpful people at your table. Thank you. 9. He can multiply for himself. And lastly, I need to represent my oxygen. AC. I have 2 oxygen inside the parentheses. I need to multiply that by my subscript of 3 for how many oxygen? 6. All right, so most of you did a fantastic job. Some of you are struggling with the last few, so let's make sure we have all of these answers. I'm going to wait for everyone to be listening carefully. Even if you feel quite confident, it's important that on a first day of learning new information that you're focused throughout the entire class. So I'll wait till everybody's with me. All right, number 3, we have a coefficient. No parentheses, no subscripts. Katie Grace, tell me how you worked this one.
I just for everyone it's 2 because 2 comes to
The 2, good. The 2 is distributed to each element after it. So then we would have 2 of each with a total of what?
6.
Good. Not too bad so far. It starts getting more complicated when we have coefficients, parentheses, and subscripts. All right, number 4. Mark, will you talk us through how you completed number 4?
Alright, well, potassium is just itself, so it has 1. Whatever chemical is.
Manganese.
We have 1 is oxygen, that's 4 of them, so it's 1 is 4.
Okay. Now, Mark, can you tell me why the 4 did not apply to the manganese or the potassium?
Because it is, it's not in parentheses.
It's not in parentheses, therefore the subscript only applies to the element directly preceding it. Good. Number 5. We have no parentheses. We have no coefficients. Sarah, would you like to try this one?
Sure. Okay, so I just pulled apart for K2, I just put 2 for that, for potassium, and then there was 1 sulfur, and there was 4 oxygen, so I got a total of 7.
Very good. Questions so far? Number 6, we have now a coefficient along with several subscripts. Carly, you want to walk me through how you tried this one?
Yes.
Okay.
For hydrogen, I did the coefficient times the subscript of 2,
And you got?
12.
Very good. She said she multiplied the coefficient times the subscript of 2 for 12 hydrogen atoms.
And for sulfur, the coefficient was 6.
Good. Just multiplied by the coefficient. It did not have a subscript.
And for oxygen, I did the coefficient times the subscript of 4, not 24.
Very good. 6 times the subscript of 4 for 24 for a total of?
42.
Very nice. All right, continuing on. Cameron, would you like to try number 7?
Okay. What? Should I say?
Number 7. So let's look at silicon first. Is there a coefficient? No. Does this subscript apply to it?
No, it only applies to stuff in the parentheses.
Very good. It only applies to what's in the parentheses. So silicon is left as a loner on its own.
1.
Very good. Now, this subscript does apply to everything inside.
4 times 1 is 4.
Hmm?
And then 4 times 1 is 4. And then 4 times 3 is 12.
Very good. You multiplied these for 12 for a total of?
21.
Good. Nicely done. Only 3 more. Number 8. Do I have a volunteer that has not shared yet? All right, Blake.
Okay, so I distributed the 2 to the H and the N and the O.
Okay, very good.
And for the H I got 2. And for the N I also got 2. And then for the O I got 6 because we have to multiply the subscripts by 2.
Very good. Nice work. All right, number 9. Hunter, do you want to do number 9?
Yes. So the 2 applies to everything. So 2 times AO, I think 2. And then we also placed the C in code. And 2 times C would be 2. And 2 times 2 is 4, but 3 times 2 is 6. So 4 times 6 is 2.
So which one are we on?
9. So it,
No, I mean which element? I'm sorry, which element? So let's look right here. Do we have? Okay, so let's look at Y. And these two are our challenging ones simply because they're being affected both by the coefficient and by the subscript. So his initial thought was, okay, well, the coefficient applies to the oxygen, but you can't forget that so does the subscript outside of the parentheses. So the oxygen is getting the distribution from the coefficient as well as the subscript. So you have to multiply both of those. So could we change this answer, Hunter?
yes.
2? 6, good. Same thing applies for the oxygen. Go ahead.
3 times 2 is 6.
Uh-huh.
And 2 times 6 is 12.
Times 6 is 12. Good. For a total of? Bye, Bruce. Very good. And the last one. I promised. Have you done one?
No.
You did. You got 2. All right, Dodger. All right, guys, there's going to be plenty of practice. Fear not. Okay, Dodger, talk us through this last one. I'm going to wait for just a second. We want to make sure everybody's listening. If your neighbor's talking or not paying attention, you should tap them on the shoulder and point to where they should be. Oh, there we go. We're all together now. Go ahead, Dodger.
Okay, I multiplied 3 by 2, so B or whatever,
What is B?
wrong.
Good.
And that equaled 6.
Okay.
And then before I did the coefficient, I decided to do the parentheses and the other subscript.
All right.
C times 3 is 3. And then 03 times 3 is 9.
So you multiplied the subscript
Yeah.
first, okay?
And then I multiplied 3 by C3, which equals 9. And the 3 times 9 equals 27. And you get 22.
For a total of?
42.
Very good. It's all right in here. So that's as hard as they really come, where you're having to multiply by coefficients and subscripts. Okay, and sometimes you'll have multiple subscripts. You might have subscripts inside and outside of the parentheses and a coefficient. So you just have to practice making sure you're multiplying by everything. I'll tell you what, you'll get real good at these, and then you'll get really confident, and then you'll start making careless errors and forgetting to multiply by certain things because you're rushing. So it'll be really important as we go forward that you really work on taking your time and making sure you've multiplied correctly by all of your coefficients and subscripts. Any questions?